Welcome back. Happy Ellipse Day. Here we go with some more ellipse examples. Write the equation for the ellipse with foci at 2, -1 and 2, 7 and eccentricity 2/3. And I think it helps to kind of find where those points are, make a little graph as you go along to help you keep straight what's going on. So we've got a focus at 2, -1 and a focus at 2, 7. And since those are on the same vertical line directly above one another, we know we're dealing with the kind of ellipse whose major axis is vertical, because the foci are always on the major axis. And can you tell where the center would be? The center is always halfway between the foci. It's also halfway between the vertices, if we knew what those were. But it's halfway between the foci. So halfway between 2, -1 and 2, 7 would be 2, 3. Remember the midpoint formula? You kind of average these points together. 2 plus 2 is 4, divided by 2 is 2. -1 plus 7 is 6, divided by 2 is 3. So the midpoint here is 2, 3. And this is the kind of equation we're going to be using. Notice I put the a squared under the y part of the equation because we do have a vertical major axis. We have the kind of ellipse that's longer in the y direction than in the x direction. And as we said, the center is halfway between the foci at 2, 3. So if we fill in the h and the k, we're dealing with x minus 2 squared over b squared plus y minus 3 squared over a squared equals 1. Okay, we still need to know what numbers go down here for the b squared and the a squared before we have our equation. So the other clue we have, the other information that we haven't used yet, is the eccentricity is 2/3. So C is the distance from the center to either focus, and that is 4. From where y is 3 to where y is 7, or from where y is 3 to where y is -1. E equals c over a. And we know 2 of those numbers. We know the eccentricity and we know c, so we can work out a. A would be c divided by e. So 4 divided by 2/3 is the same as 4 times 3/2, which is 12 over 2 or 6. So now we know a is 6. So in the part of the equation where there's an a squared, we can put in 36. And b squared equals a squared minus c squared. Remember, a squared equals b squared plus c squared. So if you rearrange that and solve for b squared would be a squared, the biggest of those numbers, minus c squared. So here that would be 36 minus 16. Remember, c was 4, so c squared is 16. And then b squared is 20. That means b itself would be the square root of 20, but when we're writing the equation, we really just need to know what b squared is, because that's the number that goes here, and that number is going to be 20. So our answer, our equation is x minus 2 squared over 20 plus y minus 3 squared over 36 equals 1. Next example. Graph the equation 3x squared plus 4y squared equals 12. Okay, right now that doesn't look like the kind of equation that we've been looking at for ellipses. Now, if you have a sophisticated enough graphing app where you could just type in an equation like this and it would show you the graph, you could cheat and do it that way, see what it looks like. But without any help of that sort, let's see if we can figure out for ourselves, just by hand, what the graph has to look like. Okay, like I said, this does not look like the kinds of equations we've been looking at for ellipses. For one thing, all of those equations had a number 1 on the right side. And this equation has a number 12 over here. So, you know how we could fix that? How we could get from having a 12 to having a 1? We could divide both sides of the equation by 12. Yeah, so let's do that. So we divide both sides by 12. 12 over 12 would be 1. And meanwhile, over here, the 3 over 12 reduces to a 1 over 4. And the 4 over 12 reduces to a 1 over 3. So now we're looking at x squared over 4 plus y squared over 3 equals 1. And that does look like the kind of equation we've been dealing with. So can you see where the center of this ellipse would be? The x and the y don't have anything subtracted from them. So the center is just at the point 0, 0. Right? And where is the major axis? Well, first of all, the bigger number, the bigger denominator, is under the x squared. So the major axis is going to be running in the x direction, horizontally. And since a squared is 4, a would be 2. So the major axis is going to have length 2 times 2, or 4. It's going to be, if you start at the center and go 2 spaces to the right and 2 spaces to the left. And then the minor axis, well, b squared is 3. So b would be the square root of 3, which is about 1.7. So that's how far you would go in the y direction. So if you start at the center, 0, 0, and go about 1.7 spaces up and about 1.7 spaces down, that gets you the minor axis. So here's where we've done that. Here's the center at 0, 0. If I go 2 spaces in the x direction to the right, 2 spaces to the left, there's my major axis. Starting from the center 0, 0, go up about 1.7 and go down about 1.7. There's my minor axis. Now we just draw an ellipse that goes around the axes, and it looks like this. So that ellipse is the graph of that equation. The points that make up that blue ellipse are the points whose x and y coordinates satisfy this equation. For example, we have the point 2, 0. If x is 2 and y is 0, 2 squared over 4, well, that would be 4 over 4, which is 1, plus 0 squared over 3, that would be 0, and 1 plus 0 does equal 1. Next example. Find the center, vertices, foci, and eccentricity of the ellipse 3x squared plus 5y squared minus 12x plus 30y plus 42 equals 0, and sketch the ellipse. Now, this equation really doesn't look like the kind we've been looking at. So part of the challenge here is going to be to wrestle this equation into the kind of form that we've been talking about. Unless you want to cheat and just plug it into a sophisticated graphing app and see if it can draw the graph of that equation the way it is now. But if we're trying to figure it out for ourselves, here's how we would do that. Okay, I'm going to start with this equation, and I'm going to complete the square on the x parts and on the y parts. So to do that, I'm going to put the two terms that involve x together and the two terms that involve y together. So I just rearranged the terms a little bit. So it went 3x squared minus 12x, and then I left a little space, plus 5y squared plus 30y, and then I left a little space. And I got rid of the constant term here by subtracting 42 on both sides. Next thing I'm going to do is, when you look at the two x terms, I'm going to factor out the 3 in front of the x squared. The coefficient on x squared, I'm going to factor it out of both of these two terms so that it's 3 times x squared minus 4x. And in front of the y squared, we've got a 5. I'm going to factor that out from the y terms. So it's 5 times, in parentheses, y squared plus 6y. And I left a little space inside the parentheses because there's where I have to add in a number to complete the square, to give me perfect squares inside the parentheses. Remember what you add? Look at the coefficient in front of the x, take half of that and square it. Half of minus 4 would be minus 2, squared would be plus 4. And here, look at the coefficient in front of the y, take half of that and square that. That's a 9. So we're adding a 4 here and a 9 here, and we got to add the same thing to both sides of the equation. When we added the 4 inside the parentheses, it was really getting multiplied by 3. So we were really adding 3 times 4. So I got to add 3 times 4 to the right side. And I added 5 times 9, so I got to add 5 times 9 to the right side. So let's see what we have here. We have 3 times a perfect square, something that factors as x minus 2 squared. Plus we have 5 times something that factors as y plus 3 squared. And then this negative 42 plus 12 plus 45 adds up to 15. Okay, guess what happens next? We have a 15 here. We want a 1. So divide both sides by 15. The 3 divided by 15 gives you a 5 on the bottom. The 5 divided by 15 is a 3 in the denominator. And we have x minus 2 squared over 5 plus y plus 3 squared over 3 equals 1. Now we can see that we're dealing with an ellipse whose center is at the point 2, negative 3. A squared is 5, so a would be the square root of 5, about 2.2. The major axis is horizontal. The bigger number is under the x part. So the vertices would be, if you start at the point 2, negative 3, and go square root of 5 units in the x direction. You add or subtract the square root of 5 to the x coordinate. B squared is 3, so b would be the square root of 3, which is approximately 1.7. We can figure out c from the fact that c squared equals a squared minus b squared, 5 minus 3, which is 2. So c would be the square root of 2, which is approximately 1.4. So the foci are in the direction of the major axis, in the x direction. If you start at the center and go square root of 2 units in the x direction, right and left, you get to the foci. So take the x coordinate of the center and add or subtract the square root of 2 from that to get to the foci. So 2 plus and minus the square root of 2 for the x coordinates of the foci, and still just negative 3 for the y coordinate. And the eccentricity, E equals c over a. Here that would be the square root of 2 divided by the square root of 5, which is approximately 0.63. And to graph it, I would start by finding the center point, 2, negative 3, draw in the major axis. From the center, go about 2.2 spaces to the right and 2.2 spaces to the left. Then draw in the minor axis. From the center, go up about 1.7 and down about 1.7. I've got the foci marked, but they're not part of, well, they're not part of the ellipse itself, but we could find them by starting at the center and going right and left about 1.4. And for the ellipse itself, once we got the axes drawn in, just draw a nice ellipse that goes around the outside of those axes. Okay, I'll be back in the next part for one more example.